According to my conducted literature study, in 13 out of the 16 articles, machine learning techniques outperform the traditional statistical methods when predicting demand in various kinds of industries. My name is Jeroen, and I have conducted my master's thesis at NXP in 2020. The goal of my master's thesis was, how can machine learning techniques be used to improve the semiconductor demand prediction? So why is it important to improve the demand prediction? Short and long-term predictions are required to make respectively inventory management and wafer start decisions. And these are done for thousands of products at different time periods and for different customers per product. Predictions can be made at several levels of aggregation. But the prediction in this master thesis, it's done at the 5th level of aggregation, which is quite a low level. But the models are built at a higher level of aggregation, and this causes that products can interact with each other. And this is an advantage of the machine learning models compared to the traditional statistical models. Besides these aggregations, we have the 3 channel groups: direct, district fulfillment, and district mass market. The direct channel group has a low number of end customers, less demand drivers, customer program, which implies that the customer delivers the forecast to NXP, no statistical forecast is made, and the demand planner pays more attention to these types of products. District fulfillment means that you have more demand drivers, larger number of end customers, no customer program, and no statistical forecast is made. The district mass market, you have the largest amount of number of end customers, more demand drivers, no customer program, and you have a statistical forecast. So what's now the difference between the machine learning models and the traditional statistical models? Traditional statistical models use only the history of the sales, while the machine learning models can easily integrate internal and external data. Internal data is the requested order book, future order book, inventory, and external data is the consumer confidence index, purchasing managers index, and the customer stock index. And the external features have almost no influence on the 5th level of aggregation, but they do have an influence on the higher level of aggregation. And this is really interesting, and that's already one of the conclusions out of this master thesis. We use 5 different machine learning models, and these are based on the outcome of the literature study. The outcome of the machine learning models are compared with the forecast made by NXP over the year of 2019. We predict 4 months out and 9 months out. The 4 months out are used for the short-term predictions, and the 9 months out for the long-term predictions. We chose 4 different products, and each of the 4 products have 3 channel groups. So in total, we have 12 cases. In 8 of the 12 cases, the machine learning models improved the forecast compared to the forecast made by NXP. And the improvement which was realized varied in the range of 3 to 18%. Especially the district mass market channel group was in each of the cases better predicted by the machine learning models than by the forecast made by NXP. The direct channel group was only in 1 of the 4 cases better predicted by the machine learning models. And this is because of the reasons earlier mentioned. Overall, the extra trees regressor was the best predictor. But when you predict 9 months out, we only look at 1 product, but our improvement was realized of 3 to 9% in all 3 channel groups. And again, the extra trees regressor was the best performing. This is already quite a good accuracy improvement, but you can also do some additions. So you can look at a higher level of aggregation. So you can predict top-down instead of bottom-up. And when you predict top-down, the external features have an influence. While when you predict bottom-up, the external features do not have an influence. You can also predict new products or end-of-life products, and not only looking at mature products. The goal of my master thesis was, how can machine learning techniques be used to improve the semiconductor demand prediction? We saw that the accuracy improves, and that this leads to cost reductions for inventory and leads to no unnecessary wafer starts.